Welcome to the session on discrete Fourier transform DFT and Twiddle factor. First, let us start with the DFT equation. The DFT equation is given by x of k is equal to summation n equal to 0 to n minus 1 x of n to the power minus j 2 pi by n into k into n. Both k and n are varying from 0 to n minus 1. Okay, this is known as capital N point DFT. Point DFT. Now this equation is represented in matrix form also. So representing this equation in matrix form gives us x of k in square bracket meaning matrix. This is W and K is the, or I will write Kn is the Twiddle factor matrix multiplied by the matrix of x of n. The shape of the matrix is, this matrix is K cross n. It has K rows and n columns. The input matrix x of n is your n cross 1. So the output becomes K cross 1 shape. Okay. Now this Twiddle factor matrix, let us find out the DFT of some sequence x of n. So x of n, let us take 1, 2, 3, 4 and find out the DFT by this above equation. So we can write x of k is equal to the Twiddle factor matrix. The Twiddle factor matrix derivation is shown in a different video. So here I will just write the Twiddle factor matrix. So this is a 4 cross 4 matrix since both k and n are varying from 0 to 3. Okay, so, and this is your x of n. X of n is 1, 2, 3, 4. Okay, so therefore I can write x of k on the left hand side is equal to just matrix multiplication will give you the output. So 1 into 1 plus 2 into 1 plus 1 into 3 plus 1 into 4. So 1 plus 2 plus 3 plus 4. Okay. Then the next row will be 1 into 1, 1 minus j into plus 2 is minus 2j, minus 1 into 2 minus 2 and plus 2j. The third row is 1 minus 2 plus 3 minus 4. The fourth row is 1 plus 2j minus 3 minus 4j. Okay. So I will get what I will get. I will get it. Let me write the answer is equal to 1, 2, 3 plus 4 is 4 plus 6, 10. Then minus 2 Okay, so here it is 1 minus 2 minus 3. So here it is wrong. Minus 3 into plus 4j. Okay, so it is minus 2 plus 2j. This is minus 2 and this is minus 2 minus 2j. So this is your x of k. Okay, this is the finding of the DFT. Now then we will see how to find out the IDFT. Given a sequence x of k, find out the IDFT. So IDFT equation is given by x of n is equal to 1 by n summation k equal to 0 to n minus 1 x of k into e to the power plus j 2 pi by n into k into n. In matrix form of the same equation, it can be written as x of n is equal to 1 by n w matrix minus. Okay, so this is your minus, the Twiddle factor is minus kn because e is positive here, and multiplied by x of k. Okay, now let us see whether here for a symmetric matrix, since the Twiddle factor matrix is a symmetric matrix, the inverse of the matrix is very easy to find out. All the complex numbers are uh, replaced by the complex conjugate. Okay, so Wn, let us find the IDFT of x of k is equal to 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. Let us find this. What is the Twiddle factor matrix? Twiddle factor matrix is given by all the j's are replaced by minus j, all the minus j's are replaced by plus j. So this inverse Twiddle factor matrix I am writing 1 plus j minus 1. All the real numbers are kept as it is. In fact, there is no change with the real numbers. So this is the inverse Twiddle factor matrix required for taking the inverse of the DFT, and we will write x of k as given. Let us do the matrix multiplication. Okay, so this is the shape of the matrix is k cross n. This is your k cross 1, and so the output will be n cross 1. Okay, so this is your, so let us write the multiplication terms. So the first row will be the addition of all these things. Okay, so 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, so this plus 2 and minus 2j cancels, and 10 minus 4 is equal to minus 4 minus 2 plus 2 plus 2. Okay, so this is your 4. So here in IDFT equation, has to be divided by 4. Okay, so this is your, the first answer is 4. Okay, then 10, if you do this, you will get that it is your, so 10 j into minus 2 plus, so minus 2j minus 2j, 10 minus 2j plus 2j square, so minus 2. Okay, and this is your plus 2, and this is your minus j into minus 2 is plus 2j, and minus j into minus 2j is 2j square. Okay, so it is minus 2. You see that all the j terms cancels, so 10 minus 2 is 8. Then you will see 10 minus 2 plus 2j, then minus 2. Okay, 10, this is your minus, is it plus 2 minus 2j, there is a sign change, and minus 2, and this will be your plus 2 plus 2j. So you see that the j terms cancels, so 10 plus 2 12, 12 minus 2 10, 10 plus 2 is 12. Okay, and the last one you will get 10 plus 2j plus 2 minus 2 minus 2j plus 2. Okay, so we will be getting 10 plus, so we will get 16 actually. So 10, then minus 2 plus 2j, then minus 2j square is plus 2, then this will be plus 2. Yes, so you will get 10 plus 14 plus 2 16. Okay, so and you have to divide by 1 by 4, so you will get x of n is 1 2 3 4. Okay, so we have got back our x of n. So this is how you have to perform your DFT and IDFT algorithms. Now more on the Twiddle factor. Okay, so now let us concentrate more on Twiddle factor. So what is Twiddle factor? That Twiddle factor is given, it has a base and it has a power r, base n is written as e to the power minus j 2 pi by capital N, the base, here the base, into the power r. Okay, it has two properties, Twiddle factor, two properties. The first one is the periodicity property, which gives us, if the power is increased by the period, okay, this becomes your, the original r. So r plus n is replaced by r, whereas the symmetry property of the Twiddle factor is represented as if the power crosses n by 2. So if there is a power which crosses n by 2, n by 2 plus r, it is replaced by minus wn r. Okay. Now a bit on the complex and the real plane. So if we have the complex number z is equal to complex number z is represented by r e to the power j theta, it means that the complex number is represented in polar format. Here r is the magnitude of z and theta is the angle of z. So in polar format, any complex number is represented by the magnitude and the angle theta. Okay, so here we will see that the Twiddle factor is represented as the magnitude and the angle theta. Okay, so what is that? We will see that. Let us take W4 0. Okay, so what is the expression? E to the power minus j 2 pi by 4 into 0 is equal to 1. Okay, what is W41? W41 is e to the power minus j 2 pi by 4 into 1 is equal to e to the power minus j pi by 2 is equal to cos pi by 2 minus j sin pi by 2 is equal to minus j. W4 2 can be reduced by the property. Okay, so it is minus, or let me reduce the property. So W4 2 is represented by 4 by 2 plus 0. So this is your minus W4 0 is equal to minus 1, and W4 3 is, we can write it as W4 4 by 2 is 2 plus 1 is equal to minus of W4 1, it is plus of j. So let us draw this Twiddle factor on the complex plane. Okay, so this is the plane. This is the real part of the plane, and this is the imaginary axis of the plane. This is known as the complex plane. And what is the magnitude of all these things? If you see that, if you compare with the polar format, the magnitude is all 1. So magnitude is all 1 and the angle is varying. Okay, so what is W4? So this is your plus 1, this is W4 0, this value is plus 1, then W4 1, W4 1, this is minus j, then your W4 2, it is minus 1, and this is your plus j, this is W4 3. So all this, okay, falls on the circle whose radius is unity. What is the magnitude of W? Magnitude of W is 1. Okay. So the Twiddle factor is rotating on a circle with the phase theta, and if you see that the rotation is clockwise. Okay, the rotation is clockwise because the angle is, this angle is negative. Okay, so it is going clockwise. So you, if you remember this diagram, okay, you don't have to calculate W every time. So W will start from here, +1, then -j, then -1, and then +1. This is true for when the total number of points capital N is equal to 4. Okay. Now let us uh, do find out some reductions. Okay. To reduce W89. So when the power of the Twiddle factor exceeds the base, when the power of the Twiddle factor exceeds the base, we can apply the periodicity property. So what we can write the power as 8 plus 1. This is what? Let's say 1. Okay. So what is the value? E to the power minus j 2 pi by 8 into 1 is equal to e to the power minus j pi by 4 is equal to cos pi by 4 minus j sin pi by 4. So it is 1 by root 2 minus j 1 by root 2. Now, so this is 1. Another reduction we can see, this is your W power 7. So we can write it as W8, 8 by 2 plus 3. This is what? Symmetry property. So it will be minus of, okay. So another also we can apply, see, this is your minus of W8. Okay, these 3 can be written as 4 minus 1. So 8 by 2 minus 1. Okay, so it is written as minus of W8 minus 1. Okay, so it was plus. Okay, so this minus, and it was already minus. The two symmetry properties, if you apply, it will be plus. Okay, so then what is the value? Now we can calculate it orally. So W is your W8 to the power minus 1 is e to the power minus j 2 pi by 8 into minus 1. Okay, so it will be e to the power j into pi by 4 equal to cos pi by 4 plus j sin pi by 4, so is equal to 1 by root 2 plus j 1 by root 2. Okay, so this is 7 and 8. In general, if we have Wn to the power r, it can be represented as, you can take the power down, so it is 1 and n divided by r. Okay, how come? So this I am showing it here. So what is W n r is equal to e to the power minus j 2 pi by n into r. So we can take r down, so 2 pi divided by n, this r, if I take it down, so r n by r. So you see that multiplied by 1. So this is the power and this is your base. Okay, so it is equal to W1 N by R. Okay, so for example, I can show you that W4 is equal to W1 and this 8 divided by the power. Okay, so it is your, okay, so this is your, you can find out the value. Okay, W12. Okay, so this is your minus e to the power minus j 2 pi by n into 1. This is e to the power minus j pi. Okay, here cos pi minus j sin pi. Sin pi is 0, so this is minus of 1. Okay. Another instance we can see that when the you can apply these properties repeatedly also. So for instance, you have to reduce uh, W49. This can be written as W4, this 4 plus 5, applying periodicity property. So W4, again you can apply the periodicity property as long as the power becomes more than the base. You can go on applying the periodicity property. Okay, so this becomes your, this one, W41. Similarly, you can go on applying the symmetry property also. I think this video will help you a lot. So try this, listening to the video sincerely and solve more numericals like what I have shown you. Thank you.